Introduction to Psychology, the Science of Mind and Behavior. Tonight, we will begin at the very beginning with the most fundamental question of all: what is psychology? This segment will define this vast science and outline its primary goals. This foundation is essential, for it sets the stage for every lesson that will follow, from the biology of the brain to the complexities of our social relationships. As you settle in, let your mind become curious about the science of your own experience. The word psychology itself comes from the Greek words psyche, meaning soul or mind, and logos, meaning the study of. So, literally, it is the study of the mind. However, the modern definition is more precise and comprehensive. Psychology is formally defined as the scientific study of behavior and mental processes. Let's unpack that definition carefully, as every part of it is important. First, let's consider behavior. This refers to any and all of our observable actions. It is anything you do that can be directly seen and measured by others. This includes overt actions like walking, talking, or smiling. But it also encompasses more subtle physiological responses, like a change in heart rate or a galvanic skin response, which can be tracked with instruments. Behavior is the outward, visible expression of our inner world. The second part of the definition is mental processes. This is the vast, internal, and subjective dimension of our lives. These are the private, cognitive activities that others cannot directly see. Your thoughts, your feelings, your sensations, your perceptions, your memories, and your dreams, these are all mental processes. They are the silent, ongoing narrative of your consciousness. While we cannot observe a thought directly, we can infer its existence and study its effects through behavior, such as what a person says, how they solve a problem, or how they react emotionally to a story. The third, and perhaps most crucial component of the definition, is the phrase scientific study. This is what distinguishes modern psychology from philosophy or casual speculation. Psychology relies on the scientific method. This means it uses systematic, objective procedures to observe, measure, and analyze behavior and mental processes. It formulates hypotheses, collects empirical data through controlled experiments and careful observation, and then uses this evidence to draw conclusions. This commitment to science ensures that psychological knowledge is based on evidence, not just on opinion, tradition, or anecdote. Now that we have defined what psychology is, we can ask, what does it aim to achieve? The goals of psychology can be organized into four main categories. Think of these as the four questions a psychologist asks about any given phenomenon. The first goal is to describe. Before we can explain anything, we must first be able to describe what is happening in a clear and accurate way. This involves creating a detailed picture of the behavior or mental process in question. For example, a psychologist might describe the specific symptoms of a panic attack: rapid heartbeat, shortness of breath, trembling, and an intense feeling of dread. Description provides the raw data for scientific inquiry. The second goal is to explain. Once a behavior has been described, the next step is to propose an explanation for why it occurs. What are its causes? Explanation often involves developing theories that can account for the observed phenomena. For instance, an explanation for a panic attack might involve a combination of genetic predispositions, learned responses, and cognitive patterns of interpreting bodily sensations as catastrophic. The third goal is to predict. This involves stating what will happen in the future based on our current knowledge and theories. If our explanations are sound, we should be able to forecast certain behaviors under certain conditions. For example, if we understand the triggers for a person's panic attacks, we might be able to predict situations where they are more likely to occur. The fourth and final goal is to influence or control. This goal is about applying psychological knowledge to help change behavior in constructive ways. It is about promoting human welfare. This does not mean controlling people against their will. Rather, it means using scientific findings to help individuals, groups, or societies function better. Therapy, for instance, is a direct application of this goal, helping a person gain control over their anxiety, change destructive thought patterns, or improve their relationships. Educational programs, effective workplace policies, and public health campaigns are all rooted in this goal of influence. Let that concept settle in for a moment. The journey of understanding moves from describing what is, to explaining why it is, to predicting what will be, and finally, to wisely influencing outcomes for the better. To appreciate how psychology arrived at this modern definition, it helps to take a brief look into its past. Psychology's roots lie in philosophy and physiology. For centuries, philosophers like Plato and Aristotle debated the nature of the mind, knowledge, and free will. But it was in the late 19th century that psychology began to emerge as a distinct scientific discipline. A key figure in this transition was Wilhelm Wundt, a German physician and philosopher. In 1879, Wundt established the first formal laboratory for psychological research at the University of Leipzig. This event is widely considered the birth of experimental psychology. Wundt was interested in the structure of the mind itself. His approach, known as structuralism, aimed to break down consciousness into its most basic elements, sensations, feelings, and images, much like a chemist would break down a compound into its elements. Around the same time, the American philosopher and psychologist William James offered a different perspective. He was less interested in the structure of the mind and more interested in its function. Influenced by Charles Darwin's theory of evolution, James asked, "Why do we think and feel? What is the purpose or function of consciousness?" His approach, known as functionalism, focused on how mental and behavioral processes enable us to adapt, survive, and flourish in our environment. He saw the mind as a flowing stream of consciousness, constantly interacting with the world. This fundamental debate between structure and function helped to shape the diverse and dynamic field that psychology is today. The real-world relevance of this foundational knowledge is profound. Understanding that psychology is a science means we can move beyond common-sense explanations, which are often oversimplified or contradictory. Psychology provides evidence-based answers. It allows us to develop effective therapies for mental illness, create educational curricula that align with how children actually learn, design safer and more efficient workplaces, and even craft public policies that promote healthier lifestyles. It gives us a lens through which to understand our own motivations, our biases, our emotions, and our relationships with others. It is, in essence, the science of us. Now that we have a clear and formal definition for our field of study, our next logical step is to understand the biological machine that makes all of this possible. The theatre for all behavior and all mental processes is the nervous system. So, in our next lesson, we will delve into the intricate architecture of the brain and the vast network of nerves that connect it to every part of your body. The biological basis of behavior, the nervous system. In our first lesson, we defined psychology as the science of mind and behavior. Now, we turn our attention to the magnificent biological machinery that makes all thought, feeling, and action possible. This segment will explore the architecture of the nervous system. Think of this as learning the fundamental hardware before we can understand the software of the mind. As you listen, imagine this intricate network alive within you, a silent, ever-active conductor of your entire experience. The entire nervous system is a complex, interconnected web, but it can be understood by dividing it into two major, hierarchical parts. The first is the central nervous system, often abbreviated as the CNS. This system consists of the brain and the spinal cord. It is the body's ultimate command center, the seat of all conscious experience, and the coordinator of all voluntary and involuntary activity. The brain, encased within the protective skull, is where high-level processing occurs, where perceptions are formed, memories are stored, and decisions are made. The spinal cord, a long, delicate bundle of nerve tissue that travels down the spinal column, serves as the primary information highway, carrying messages between the brain and the rest of the body. It is also capable of managing simple reflex responses on its own, like pulling your hand away from a hot surface before the brain has even registered the pain. The second major division is the peripheral nervous system, or PNS. This system includes all the nerves that branch out from the brain and spinal cord to reach every other part of the body, your limbs, your organs, your skin. If the central nervous system is the command center, the peripheral nervous system is the vast communication network that carries orders out to the territories and sends sensory information back to the capital. The peripheral nervous system is itself subdivided into two important components. The first is the somatic nervous system. This system controls our voluntary movements. When you decide to lift a cup, type on a keyboard, or turn your head, the somatic nervous system is carrying the motor commands from your brain to your skeletal muscles to make that movement happen. It also carries sensory information from the outside world, sights, sounds, touches, back to the central nervous system. The other part of the peripheral nervous system is the autonomic nervous system. This system governs the involuntary, automatic functions that keep you alive. Your heartbeat, your digestion, your breathing, your glandular secretions. You do not consciously tell your heart to beat. The autonomic system manages it for you. This system is further specialized into two branches that work in a delicate, complementary balance, like the accelerator and brake pedal in a car. The first branch is the sympathetic nervous system. This is your body's mobilization system, often called the fight or flight response. When you perceive a threat or are in a stressful situation, the sympathetic system springs into action. It dilates your pupils to let in more light, accelerates your heart rate to pump more blood to your muscles, inhibits digestion to conserve energy, and triggers the release of adrenaline, preparing your body for intense physical activity. The second branch is the parasympathetic nervous system. This is your body's conservation system, often called the rest and digest response. Once a perceived threat has passed, the parasympathetic system works to calm the body down. It slows the heart rate, constricts the pupils, and stimulates digestive processes to restore and maintain the body's energy reserves. It promotes relaxation, recovery, and growth. The sympathetic system is the accelerator, preparing for action. The parasympathetic system is the brake, promoting calm and conservation. They are in a constant, dynamic dance, regulating your internal state in response to the demands of your environment. Let that concept settle in. This entire system, from the central command to the peripheral signals, is built from billions of specialized cells. The fundamental building block of the entire nervous system is the neuron, or nerve cell. Neurons are uniquely specialized for communication. A typical neuron has three main parts. The cell body contains the nucleus and keeps the cell alive. Dendrites are tree-like extensions that branch out from the cell body. Their job is to receive incoming messages from other neurons. The axon is a long, thin fiber that carries electrical impulses away from the cell body toward other neurons, muscles, or glands. Many axons are insulated by a fatty substance called myelin sheath, which acts like the insulation on an electrical wire, speeding up the transmission of the neural impulse. The real magic of communication, however, happens in the tiny gaps between neurons. These gaps are called synapses. When an electrical impulse, known as an action potential, travels down the axon and reaches its end, it triggers the release of chemical messengers. These messengers are called neurotransmitters. These neurotransmitter molecules float across the synaptic gap and bind to receptor sites on the receiving neuron's dendrites, like a key fitting into a lock. This process can either encourage the receiving neuron to generate its own electrical impulse, or it can inhibit it from doing so. This electrochemical conversation, happening billions of times every second across vast neural networks, is the physical basis of everything you are experiencing right now. The sound of my voice, the comfort of your bed, the drift of your thoughts. Key neurotransmitters include serotonin, which influences mood, appetite, and sleep. Dopamine, involved in pleasure, reward, and motor control. And glutamate, a primary excitatory neurotransmitter crucial for learning and memory. The real-world relevance of understanding the nervous system is immense. It explains the physiological jolt you feel when you are startled. That is your sympathetic nervous system flooding your body with resources for action. It clarifies why certain medications work. An anti-anxiety drug, for instance, might enhance the effect of the inhibitory neurotransmitter, GABA, thereby calming the nervous system and promoting the parasympathetic response. It also helps us understand conditions like multiple sclerosis, which involves the degradation of the myelin sheath, slowing down neural communication and disrupting motor control. Now that we have mapped the overall system of communication, our next step is to explore its most complex and fascinating organ in greater detail. With the nervous system as our guide, we can now focus our attention on the human brain itself and the remarkable structures and functions that define our very being. The brain, structure, function, and neuroplasticity. In our previous lesson, we mapped the vast network of the nervous system. Now, we journey to its central command, the most complex object we know of in the universe, the human brain. This segment will take a closer look at the brain's major structures and their specialized functions. We will also introduce one of the most empowering concepts in modern neuroscience, neuroplasticity. As you listen, imagine this 3-pound organ, soft and intricately folded, quietly orchestrating the entirety of your conscious existence. To understand the brain's architecture, it is helpful to view it through an evolutionary lens, as a structure built in layers over millions of years. The deepest and most ancient layer is often called the hindbrain, located at the base of the skull where the spinal cord enters. This region is responsible for our most fundamental life support functions. It includes structures like the medulla oblongata, which automatically regulates your heartbeat, breathing, and blood pressure. You do not consciously decide to breathe. The medulla manages this vital rhythm for you. Also residing in the hindbrain is the cerebellum, a distinctive, cauliflower-shaped structure tucked at the back of the brain. The cerebellum is the master coordinator of voluntary movement, balance, and posture. It fine-tunes your motor commands, allowing you to walk smoothly, reach for a glass of water without spilling it, or learn the complex finger movements required to play a musical instrument. Without the cerebellum, our movements would be jerky and uncoordinated. Sitting just above the hindbrain is the limbic system, a collection of structures that form a border around the brainstem. This area is often referred to as the emotional brain because it plays a pivotal role in our emotional life, memory formation, and basic drives. Two key components of the limbic system are the amygdala and the hippocampus. The amygdala is an almond-shaped cluster of neurons that acts as our emotional alarm system. It is crucial for processing emotions, particularly fear and aggression. When you feel a sudden jolt of anxiety or react instinctively to a perceived threat, your amygdala has been activated. The hippocampus, named for its seahorse-like shape, is the gateway to memory. It is essential for forming new, conscious memories of facts and events, a process known as consolidation. It is the hippocampus that helps you remember what you had for breakfast, or the details of a conversation. If the hippocampus is damaged, a person may lose the ability to form new memories, even while their memories from before the damage remain intact. The outermost and evolutionarily newest layer of the brain is the cerebrum. It is what we typically picture when we think of a brain, a large, wrinkled dome divided into two hemispheres. This wrinkled surface is the cerebral cortex, a thin, deeply folded layer of tissue that is the seat of our highest cognitive functions. It is here that we think, plan, perceive, and use language. The cerebrum is divided into a left and a right hemisphere, which are connected by a thick bundle of nerve fibers called the corpus callosum. This bundle allows the two hemispheres to communicate and coordinate with each other. While they work together, each hemisphere has some specialized functions, a concept known as lateralization. For instance, for most right-handed people, the left hemisphere is more dominant for language and logical reasoning, while the right hemisphere is more involved in spatial awareness, facial recognition, and processing the emotional tone of language. The cerebral cortex of each hemisphere is further divided into 4 lobes, each named for the skull bones that cover them. The frontal lobes, located directly behind your forehead, are the executive center of the brain. They are responsible for planning, decision-making, personality expression, and voluntary motor control. When you make a conscious choice, solve a complex problem, or exert self-control, your frontal lobes are hard at work. Moving toward the back of the head, we find the occipital lobes. These lobes are almost exclusively dedicated to visual processing. They interpret information from your eyes, allowing you to perceive shapes, colors, and movement. The parietal lobes are situated at the top and toward the back of the head. They process sensory information from the body, known as somatosensation, which includes touch, temperature, and pain. A specific strip in the parietal lobe, called the somatosensory cortex, creates a map of your body surface. Finally, the temporal lobes, located on the sides of the head near your temples, are crucial for auditory processing and are also deeply involved in memory, and in the left hemisphere particularly, language comprehension. Let this intricate image of the brain rest in your mind for a moment, a layered organ with ancient parts, managing survival, and modern parts crafting conscious thought. For a long time, it was believed that the brain structure was largely fixed by early adulthood, that it was a static, hardwired machine. We now know this is profoundly untrue. The brain possesses a remarkable quality known as neuroplasticity. The term neuroplasticity comes from neuron and plastic, meaning malleable or changeable. It refers to the brain's enduring capacity to reorganize itself by forming new neural connections throughout life. This process is the physical basis of learning. When you repeatedly practice a new skill, whether it is speaking a foreign language or playing a chess opening, the neural pathways involved in that skill are strengthened. The brain literally rewires itself in response to experience. This is often summarized by the famous phrase from psychologist Donald Hebb: "Neurons that fire together, wire together." Neuroplasticity also means that the brain can compensate for injury. If one area is damaged, other areas can sometimes reorganize and take over some of its functions. The real-world relevance of this knowledge is transformative. Understanding the brain's functional layout helps neurologists locate the site of a stroke or trauma. But understanding neuroplasticity gives us hope and agency. It is the reason why stroke patients can, through rigorous and consistent therapy, relearn how to speak or walk. Their brains are forming new connections around the damaged area. It means that when you learn a new concept in this very session, your brain is changing. Your daily habits, your thoughts, and your experiences are actively sculpting your neural architecture. This knowledge empowers us to see the brain not as a fixed blueprint, but as a dynamic, living garden that we can cultivate through our actions and attention. Now that we have explored the internal theater of the mind, we must understand how it engages with the world outside. Our brain does not exist in a vacuum. It is constantly processing a flood of information from our senses. This brings us to our next essential topic: the processes of sensation and perception. Sensation and perception, the doors to experience. In our last lesson, we explored the human brain, the complex organ that serves as the seat of all our experiences. But this brain does not operate in isolation. It is in a constant, dynamic conversation with the world outside itself. This segment delves into that conversation, distinguishing between 2 related but distinct processes: sensation, which is how we detect physical energy from the environment, and perception, which is how we interpret that energy to create our meaningful experience of reality. As you listen, consider the seamless way your mind transforms mere light and sound into the rich tapestry of your conscious world. Sensation is the fundamental starting point, the process by which our sensory receptors and nervous system receive and represent stimulus energies from our environment. It is the raw data entry into the system. Think of sensation as a door. The world is full of various forms of energy: light waves, sound waves, chemical molecules, pressure, and temperature changes. Our body is equipped with specialized keyholes for these energies, which we call sensory receptors. For vision, photoreceptors in the retina of the eye detect light waves. For hearing, hair cells in the inner ear detect sound waves. For smell and taste, chemoreceptors in the nose and mouth detect chemical molecules. And for touch, thermoreceptors and pressure receptors in the skin detect temperature and physical pressure. Each of these receptor types is uniquely designed to convert a specific type of environmental energy into electrochemical signals that the brain can understand, a process known as transduction. Sensation, therefore, provides the basic, unprocessed facts about the world: a wavelength of light, a frequency of sound, a molecular shape. Perception, however, is the next and truly remarkable step. Perception is the process of organizing and interpreting the sensory information that has been delivered by sensation. It is what allows us to recognize meaningful objects and events, to see not just patches of color and shape, but a face, to hear not just a chaotic series of vibrations, but a spoken word or a melody. If sensation is about gathering the raw data, perception is about the brain's sophisticated analysis and interpretation of that data. It is the act of giving meaning to the sensory input. For instance, the sensation from your eyes might provide information about a curved, reddish-orange shape. It is perception that assembles this information and identifies it as an apple. This distinction is crucial. Our experience is not a perfect recording of the world, but a constructed interpretation of it. A key concept that bridges sensation and perception is the idea of thresholds. The absolute threshold is defined as the minimum stimulation needed to detect a particular stimulus 50% of the time. It is the faintest whisper of a sound that you can just barely hear, the most diluted drop of sugar in water that you can just barely taste, the most distant candle flame that you can just barely see on a dark, clear night. This threshold varies from person to person and moment to moment, defining the very boundaries of our sensory awareness. Below this threshold, stimuli are considered subliminal, and while they may have subtle effects, they operate outside our conscious perception. Another important type of threshold is the difference threshold, which is the minimum difference between two stimuli required for detection 50% of the time. This is sometimes called the just noticeable difference. An interesting principle here is Weber's law, which states that for two stimuli to be perceived as different, they must differ by a constant minimum percentage, not a constant amount. This means that in a quiet room, adding a single candle to a single candle is a dramatic 100% increase in light, and you would notice it easily. But adding one candle to a bonfire of 100 candles is a negligible increase, and you would be unlikely to perceive any change at all. Let that concept settle in. Your conscious awareness of the world has a minimum volume, a minimum brightness, a definable limit. Now, how does the brain accomplish the incredible feat of perception? A major mechanism is known as top-down processing. This is when our perceptions are guided by higher-level mental processes, such as our experiences, expectations, beliefs, and context. We do not simply build a perception from the ground up using only the sensory data. We use our existing knowledge to quickly interpret the fragments of information we receive. A classic example of top-down processing is your ability to read this sentence, even if some of the words are misspelled or letters are jumbled. Your brain uses its knowledge of language and context to automatically fill in the gaps and arrive at the correct meaning. Another powerful demonstration is the phenomenon of perceptual set, which is a mental predisposition to perceive one thing and not another. If you are expecting to see a friend in a crowd, you are far more likely to recognize them, because your brain is primed for that specific perception. Your expectations, your mood, and your cultural background all create a perceptual set that influences how you interpret the ambiguous sensory world. The real-world relevance of understanding sensation and perception is vast and touches every aspect of our lives. It explains the captivating nature of optical illusions, where our perceptual systems are tricked into seeing a reality that does not physically exist. This happens because our brain applies its usual rules of organization, like interpreting converging lines, as indicating depth to a two-dimensional image, creating a compelling but false perception. This knowledge is also fundamental to design and safety. Engineers design airplane cockpits and road signs with perception in mind, ensuring that critical information is presented in a way that is easy to detect, distinguish, and interpret quickly under pressure. In the world of marketing, the subtle use of color, sound, and scent are all carefully chosen to influence our perceptions and, consequently, our behavior. Even something as common as the cocktail party effect, your ability to focus your auditory attention on a single conversation in a noisy room, is a fascinating example of how our perception actively selects what is important from a chaotic sensory background. Now that we have explored how we take in information from the world, our next logical step is to understand what we do with it. How does this constant stream of sensory experience lead to lasting change in our behavior? This brings us to one of the most fundamental topics in all of psychology, the principles of learning. Learning and conditioning, associating with our world. In our last segment, we explored how we take in information about the world through our senses. But a mind that only perceives is a mind trapped in the present moment. The crucial next step is learning the process that allows our experiences to shape our future behavior. This segment covers the fundamental principles of learning, the mechanisms through which we adapt to our environment, form habits, and acquire new knowledge. As you listen, consider how your own life has been a continuous tapestry of learning, from your earliest memories to the skills you use every day. Learning, in a psychological context, is defined as a relatively permanent change in behavior or knowledge that results from experience. This definition has three key parts. First, it is a change that endures. It is not a temporary fluctuation like fatigue or a fleeting thought. Second, this change must be based on experience, which excludes behaviors we are born with, like reflexes. And third, the change can be in an observable action or in an internal understanding. Much of what we understand about learning comes from the study of associative learning, which is when we learn to link two events that occur close together. There are two primary forms of this associative learning, each discovered through landmark research that forever changed our understanding of behavior. The first form is classical conditioning, a type of learning that was accidentally discovered by the Russian physiologist Ivan Pavlov in the early 1900s. Pavlov was studying the digestive system of dogs when he noticed something fascinating. The dogs would naturally salivate when food was placed in their mouths. This is a natural, unlearned reflex. But after a while, the dogs began to salivate at the sight of the lab assistant who fed them, or even at the sound of the assistant's footsteps. They had learned to associate a neutral stimulus with a biologically significant event. Pavlov decided to investigate this systematically. He began to ring a bell just before presenting the food to the dogs. At first, the bell was a neutral stimulus, meaning it caused no relevant response, perhaps just a pricking of the ears. The food, however, was an unconditioned stimulus, meaning it naturally and automatically triggered a response without any learning needed. The response to the food, salivation, was an unconditioned response, again, a natural, reflexive reaction. After repeatedly pairing the sound of the bell with the presentation of the food, something remarkable happened. The bell alone began to trigger salivation. The bell was no longer a neutral stimulus, it had become a conditioned stimulus, and the salivation in response to the bell alone was now a conditioned response, a learned reaction. The dogs had learned to associate the bell with the arrival of food. This process demonstrates how neutral elements in our environment can take on significant meaning through association. If you have ever felt a surge of hunger when you hear the familiar jingle of an ice cream truck, or felt your heart beat faster at the sound of a dentist's drill, you have experienced the principles of classical conditioning at work in your own life. The second major form of associative learning is operant conditioning, which was extensively studied and popularized by the American psychologist B.F. Skinner. While classical conditioning is about learning associations between stimuli, operant conditioning is about learning associations between our own behavior and its consequences. In essence, we learn to operate on our environment to produce a desired outcome. Skinner developed a specialized chamber, often called a Skinner box, to study this in a controlled way. In a typical experiment, a rat inside the box would accidentally press a lever, which would deliver a food pellet. The consequence of the behavior receiving food made it more likely that the rat would press the lever again. The food pellet in this case served as a reinforcer, which is any event that strengthens the behavior it follows. Reinforcement can be positive or negative, but both serve to increase a behavior. Positive reinforcement adds a desirable stimulus. Getting a reward for good work, receiving a compliment, or earning a good grade are all examples of positive reinforcement that make you more likely to repeat the behavior that led to them. Negative reinforcement involves removing an aversive or unpleasant stimulus. When you take a painkiller to get rid of a headache, and the relief makes you more likely to take that painkiller again in the future, that is negative reinforcement. The behavior of taking the pill is strengthened by the removal of the headache. It is crucial to remember that negative here means removal, not bad. On the other side of the equation is punishment, which is any consequence that decreases the likelihood of a behavior. Punishment can also be positive, by applying an unpleasant consequence like a parking ticket, or negative, by taking away something desirable, like revoking a teenager's driving privileges for a broken rule. Let that concept settle in. Your actions are constantly being shaped by their outcomes, a silent process of behavioral sculpting that occurs throughout your day. The work of these pioneers did more than just explain animal behavior. It provided a powerful framework for understanding human learning. Classical conditioning helps explain why a particular song can evoke a strong wave of nostalgia from your past, or why a specific smell might instantly transport you to your grandmother's kitchen. It is the mechanism behind certain phobias, where a neutral object becomes associated with a traumatic event, triggering a fear response. Operant conditioning, on the other hand, is the engine behind most of our habitual behaviors. We continue to go to work because we receive a paycheck. We are polite to others because this behavior is reinforced by positive social interactions. We avoid touching a hot stove because we were punished by the pain once before. These principles are consciously applied in countless domains, from training a dog with treats to designing token economies in classrooms where children earn rewards for positive behavior, to structuring employee bonus programs in the workplace. Now that we understand how we learn from our experiences, we must next explore how we retain those experiences. The information we learn must be stored for future use. This brings us to one of the mind's most fascinating and essential capabilities, the intricate system of memory. Memory, encoding, storage, and retrieval. In our last lesson, we explored how learning allows experience to shape our behavior, but for that learning to have any lasting impact, it must be preserved. This brings us to one of the mind's most essential and fascinating capabilities, memory. Memory is the persistence of learning over time, the mental faculty that allows us to retain information and recall it later. In this segment, we will explore the architecture of memory, the journey a thought or experience takes from a fleeting impression to a lasting record. As you listen, consider the vast library of your own mind, filled with the stories, facts, and skills that define your personal history. To understand how memory works, psychologists often break it down into three fundamental sequential operations: encoding, storage, and retrieval. Think of these as the life cycle of a memory. Encoding is the first and crucial step. It is the process of getting information into the memory system. Your brain is constantly bombarded with sensory data, and encoding is the act of converting that data into a neural code that your brain can work with. It is like a translator taking in a foreign language and turning it into your native tongue. This process often requires effort and attention. For example, when you meet someone new, you must actively pay attention to their name to encode it properly. If your mind is elsewhere, the name may never even enter your memory system, despite you hearing it. Encoding can be acoustic, emphasizing how something sounds, semantic, emphasizing its meaning, or visual, emphasizing how it looks. If encoding is the process of writing information down, Then storage is the process of filing it away for future use. Storage is the retention of the encoded information over time. This is not a single process, but involves different storage systems that hold information for varying lengths of time. The classic model of memory storage describes 3 stages. The first is sensory memory, which is the immediate, very brief recording of sensory information. It is a perfect, but fleeting, snapshot of your sensory experience. Iconic memory, for visual stimuli, lasts for just a fraction of a second, just long enough for your brain to decide if the information is important. Echoic memory, for auditory stimuli, lasts a little longer, about 3 to 4 seconds, which is why you can often hear a question someone just asked you even if you weren't initially listening. If information from sensory memory is deemed relevant, it is transferred into short-term memory. This is your conscious, working memory. It is where you hold information temporarily, like a mental scratch pad. You use short-term memory to remember a phone number just long enough to dial it, or to hold the beginning of this sentence in mind as you read its end. However, short-term memory is severely limited in both its capacity and its duration. It can only hold about 7, plus or minus 2, unrelated items for about 20 to 30 seconds without rehearsal. To keep information in short-term memory, you must repeat it, a process known as maintenance rehearsal. The final stage is long-term memory. This is the relatively permanent and limitless storehouse of all your knowledge, skills, and experiences. It is everything you know, from your childhood memories to the capital of France, from how to tie your shoes to the lyrics of a favorite song. The transfer of information from short-term to long-term memory is facilitated by a process called elaborative rehearsal, which involves making the information meaningful by connecting it to knowledge you already possess. When you successfully store a memory in long-term memory, you have created a lasting physical change in your brain's neural connections. The third and final memory process is retrieval. This is the process of getting information back out of storage. It is the act of recall. Retrieval can be as simple as recognizing the correct answer on a multiple-choice test, or as effortful as the free recall required to answer an essay question. Retrieval is not like playing a video recording, it is an active reconstruction. The context in which you try to retrieve a memory is incredibly important. The encoding specificity principle states that cues and context present at the time of encoding are often the most effective triggers for retrieval. This is why returning to a place from your childhood can suddenly flood you with memories you hadn't accessed in years. The context itself serves as a powerful retrieval cue. Let that concept settle in. Your memory is not a single vault, but a multi-stage processing system, from a fleeting sensory impression to a conscious thought, to a potentially permanent part of your life story. Now, let's take a deeper look into the vast warehouse of long-term memory. It is helpful to divide it into 2 major types. The first is explicit memory, also known as declarative memory. These are the memories of facts and experiences that you can consciously know and declare. You can explicitly recall your birthday, the rules of a game, or what you had for dinner last night. Explicit memory is further divided into semantic memory, which is your store of general knowledge and facts, like knowing that Paris is the capital of France, and episodic memory, which is your memory of specific personal events, like your last birthday party. The second major type is implicit memory, also known as non-declarative memory. These are memories that influence your behavior and cognition without any conscious effort. They include procedural memory, which is the memory for skills and habits, like how to ride a bike or type on a keyboard. You don't consciously recall the individual motions, you just perform them. Implicit memories also include classically conditioned responses, like the fear you might feel when you see a dentist's drill. The work of psychologist Elizabeth Loftus has profoundly shaped our understanding of memory, particularly its reconstructive nature. Her research demonstrates that memory is not a perfect photographic recording. Instead, when we retrieve a memory, we are actively rebuilding it, and this process is susceptible to distortion. Post-event information, such as leading questions or suggestions from others, can easily be incorporated into our memory, altering it. This is why eyewitness testimony in legal cases, while powerful, can be surprisingly unreliable. A memory can feel incredibly vivid and real to you, yet contain significant inaccuracies implanted after the fact. The real-world relevance of understanding memory is immense. It directly informs how we should study and learn. Cramming information the night before a test relies on short-term memory and leads to quick forgetting. A far more effective strategy is spaced repetition, studying information over multiple spread-out sessions, which strongly encourages encoding into long-term memory. Similarly, making information personally meaningful or connecting it to what you already know uses elaborative rehearsal to create a much stronger and more retrievable memory. Understanding the fallibility of memory also encourages humility about our own recollections and caution in interpreting the memories of others. Now that we understand how we retain and recall information, we can move beyond simple storage to explore the more active processes that use this information. Memory allows us to reflect on the past, while cognition empowers us to think, reason, and solve problems for the future. Let's explore the processes of thought in our next lesson. Cognition and thinking, problem solving, and decision making. In our last segment, we explored memory, the vast library of our past experiences. But the human mind is not merely a storage device, it is an active and dynamic processor of information. It uses the contents of memory to reason, to create, and to navigate the future. This segment moves us into the realm of cognition, the mental activities associated with thinking, knowing, remembering, and communicating. We will explore how we form concepts, solve problems, and make decisions. And we will uncover some of the common mental shortcuts that can both aid and hinder our judgment. As you listen, observe the quiet flow of your own thoughts, the very processes we are about to understand. The foundation of much of our thinking is the concept. A concept is a mental grouping of similar objects, events, ideas, or people. It is a cognitive tool that simplifies our world. We do not have a unique mental file for every single tree we have ever seen. Instead, we have a concept for tree, which allows us to recognize an endless variety of oaks, pines, and maples as belonging to that same category. Concepts are often organized around prototypes, which are the mental images or best examples of a category. When you think of a bird, you might quickly bring to mind a robin or a sparrow, rather than a penguin or an ostrich. That robin is closer to your prototype for bird, even though all are technically birds. This use of prototypes allows for quick and efficient thinking, enabling us to make rapid judgments without deliberate analysis. When we face a new challenge or goal, we engage in problem solving. This cognitive process involves moving from a given state to a desired goal state. To do this, we often employ different strategies. One such strategy is an algorithm. An algorithm is a step-by-step procedure that guarantees a solution. It is a logical, systematic recipe. Following a mathematical formula to solve a long division problem is using an algorithm, so is carefully following the instruction manual to assemble a piece of furniture. While algorithms are reliable, they can often be slow and methodical. A much faster, but less reliable, approach is the use of heuristics. A heuristic is a simple thinking strategy, a mental shortcut that allows us to make judgments and solve problems efficiently. Heuristics are often called rules of thumb. For example, if you are trying to decide which of two restaurants is more popular, you might use the recognition heuristic and choose the one whose name you recognize. Or, if you are trying to determine the probability of an event, you might use the representativeness heuristic, making a judgment based on how well an object or event seems to match your prototype. While heuristics are usually helpful, they can sometimes lead us to ignore other relevant information. Another common obstacle in problem solving is a mental set, which is our tendency to approach a problem with the mindset that has worked for us in the past. A mental set is like a well-worn path in your mind. It's comfortable and familiar. But if a new problem requires a fresh approach, the mental set can blind you to novel solutions. Imagine a chef who only knows how to cook with wheat flour, struggling to bake a cake for a friend with a gluten allergy. Their mental set may prevent them from readily exploring alternative flours like almond or coconut. Let that concept settle in. Your mind is constantly using these efficient shortcuts to navigate the world, saving conscious effort for the most demanding tasks. Now, let us take a deeper dive into the world of judgment and decision-making. This is where the work of psychologists Daniel Kahneman and Amos Tversky has been revolutionary. They identified systematic errors in human reasoning, which they called cognitive biases. These biases are the predictable byproducts of our reliance on heuristics. One of the most pervasive is confirmation bias. This is our tendency to search for information that confirms our preconceptions and to ignore or distort evidence that contradicts them. If you believe that a certain political party always handles the economy better, you will likely notice and remember news stories that support this belief, while dismissing or forgetting stories that challenge it. Confirmation bias creates an echo chamber of our own existing beliefs. Another powerful cognitive shortcut is the availability heuristic. This is our tendency to estimate the likelihood of an event based on how easily instances of it come to mind. What we can recall most vividly feels more common. For example, after seeing several news reports about airplane crashes, you might feel that air travel is extremely dangerous, even though statistics clearly show it is one of the safest modes of transportation. The dramatic, vivid images of a crash are more available in your memory than the countless uneventful flights that occur every day. Similarly, people often overestimate the rate of violent crime because these stories are prominently featured in the media, making them easily recallable. The real-world relevance of understanding cognition and its potential pitfalls is profound. In the field of education, teaching students about these cognitive biases can help them become more critical thinkers, better equipped to evaluate information and avoid logical fallacies. In the realm of finance and economics, behavioral economics directly applies these principles to understand why people make irrational financial decisions, such as selling stocks in a panic during a market dip or holding on to losing investments for too long due to a reluctance to admit a loss. In our daily lives, understanding confirmation bias can encourage us to actively seek out opposing viewpoints, making us more empathetic and better informed citizens. Recognizing the availability heuristic can help us make calmer, more statistical assessments of risk, rather than being swayed by sensational but rare events. Our thoughts are intricate and powerful, but for them to have an impact beyond our own minds, they must be shared. This leads us to the most sophisticated tool for thinking and communication that humans possess. Our next topic is the unique human capacity for language. Language and communication. In our last lesson, we explored the intricate processes of cognition and thought, but these private reflections gain their full power when they are shared. This brings us to one of the most defining features of the human mind, our capacity for language. Language is our spoken, written, or signed system for communication, and it is far more than a simple tool. It is the primary vehicle through which we transmit culture, articulate complex ideas, and weave the fabric of society. This segment will deconstruct the architecture of language and explore the fascinating psychological question of how we acquire this remarkable skill. As you listen, consider the effortless way you are processing these words, a feat that represents one of the most complex achievements of the human brain. To understand language, we must first look at its hierarchical structure, the building blocks that combine to create an infinite variety of expression. At the most basic level, we have phonemes. These are the smallest distinctive units of sound in a language. A phoneme is not a letter, but a sound. For example, in English, the sounds represented by the letters P and B are different phonemes, which is why the words pat and bat have different meanings. English uses about 40 phonemes, while other languages may use more or fewer. These sounds are the raw materials of speech. These phonemes combine to form the next level of structure, morphemes. A morpheme is the smallest unit of language that carries meaning. Some morphemes are whole words, like dog or run. These are free morphemes. Others are prefixes or suffixes, like the un in undo or the ed in walked. These are bound morphemes, and they cannot stand alone, but can change the meaning of a word. The word unhappiness, for instance, contains three morphemes, un, happy, and ness. Once we have words, we need rules to combine them into sentences. This is the domain of grammar, the system of rules that enables us to communicate with and understand others. Grammar has two main components. The first is syntax. Syntax is the set of rules for combining words into grammatically sensible sentences. It is the grammatical structure that dictates word order. In English, we understand that the cat chased the dog has a different meaning from the dog chased the cat, because we have an implicit understanding of syntactic rules. The second component is semantics. Semantics refers to the rules we use to derive meaning from morphemes, words, and sentences. It is the study of meaning. The semantic rule tells us that adding ed to a verb like walk generally places the action in the past. Together, syntax and semantics allow us to generate and understand a virtually limitless number of novel sentences, a property known as the generativity of language. Let that concept settle in. From a finite set of sounds and rules, you can create and comprehend an infinite number of ideas, from the simplest observation to the most profound philosophical argument. Now, let's take a deeper dive into one of the most enduring debates in psychology. How do we acquire this complex system? Is language a learned skill, like riding a bicycle, or is it an innate biological capacity? The behaviorist B.F. Skinner proposed that language is learned primarily through operant conditioning. He suggested that infants learn to speak through imitation, reinforcement, and shaping. A baby babbles, makes a sound that resembles mama, and is rewarded with hugs and delighted smiles, thereby reinforcing that sound. While learning plays a crucial role, this theory struggles to explain the rapid pace and universal patterns of language acquisition. In contrast, the linguist Noam Chomsky argued that humans are born with a biological predisposition for language. He proposed the concept of a language acquisition device, an innate mental module that is pre-wired to understand the universal rules, or universal grammar, common to all human languages. Chomsky noted that children all over the world progress through similar stages of language development at roughly the same age, and they often overgeneralize grammatical rules, saying things like, "I go-ed" instead of "I went." This suggests they are not merely imitating, but are unconsciously applying a mental rule. This innate capacity is supported by the critical period hypothesis, which suggests that there is an ideal window, typically in early childhood, during which language can be acquired most easily. If a child is not exposed to language during this period, as tragically seen in cases of extreme isolation, their ability to master grammar and syntax may be permanently impaired. The real-world relevance of understanding language is immense. The critical period hypothesis underscores the profound importance of talking, reading, and singing to young children, as their brains are exquisitely primed to absorb linguistic structure during these early years. It also explains why learning a second language is typically far easier and results in more native-like pronunciation for children than for adults, who are learning outside of that optimal window. Furthermore, understanding the components of language helps in diagnosing and treating language disorders, such as aphasia, which is a loss of language ability due to brain damage. For instance, damage to one area of the brain might affect syntax, making speech sound telegraphic, while damage to another area might affect semantics, rendering speech fluent but meaningless. On a broader scale, the study of language reveals the deep connections between our words and our thoughts, a concept known as linguistic relativity, which suggests that the language we speak can influence how we think about and perceive the world. Our ability to communicate through language allows us to share our inner world, but what is it that drives us to speak, to act, to strive in the first place? The intricate systems of thought and language are powered by deep internal forces. This brings us to our next area of exploration, the powerful and intertwined realms of motivation and emotion. Motivation and emotion, the drivers of behavior. In our last lesson, we explored the remarkable human capacity for language, the system that allows us to share our inner world. But what is the content of that inner world? What are the forces that energize and direct our behavior, that color our experiences with feeling and purpose? This segment delves into the core drivers of human experience, motivation and emotion. Motivation is the process that activates, guides, and maintains our behavior toward a goal. Emotion is a complex reaction that involves our physiology, our behavior, and our conscious feelings. Together, they form the psychological fuel and the experiential quality of our journey through life. As you listen, turn your attention inward to the subtle currents of desire and feeling that are always present within you. Let us begin with motivation, the why behind our actions. One of the most influential frameworks for understanding human motivation is Abraham Maslow's hierarchy of needs. Maslow proposed that our motivations are not random. They are organized in a pyramid-like hierarchy, from the most basic biological needs to the most advanced psychological aspirations. At the foundation of the pyramid are our physiological needs. These are the requirements for physical survival, such as the need for food, water, warmth, and rest. Until these needs are reasonably satisfied, they dominate our attention and motivate our behavior. A person who is starving is not preoccupied with writing a novel or building a friendship. Their entire being is focused on finding food. Once the physiological needs are met, the next level of the pyramid emerges, the need for safety and security. This includes the desire for a stable environment, for protection from harm, for a predictable world. When we seek shelter, save money, or look for a stable job, we are motivated by our safety needs. With these needs fulfilled, we then become motivated by our social needs, the need for love and belonging. This is the deep-seated desire to form and maintain strong, stable interpersonal relationships, to feel part of a family, a circle of friends, a community. The feeling of loneliness is a powerful signal that this need is unmet. The next level is the need for esteem. This involves both self-esteem, the need for achievement, mastery, and competence, and the esteem from others, the need for recognition, respect, and status. Finally, at the very peak of the pyramid, lies the need for self-actualization. This is the desire to realize one's fullest potential, to become everything one is capable of becoming. It is the motivation for personal growth, creativity, and fulfilling one's unique purpose. While this hierarchy is a helpful metaphor, it is important to remember that human motivation is fluid, and these levels are not rigidly fixed. Now, let us turn to emotion, the feeling state that is often intertwined with our motivations. An emotion is a full-body response that involves physiological arousal, expressive behaviors, and conscious experience. When you feel the emotion of fear, for example, your body undergoes a physiological change. Your heart rate accelerates, your muscles tense, and your pupils may dilate. You also exhibit expressive behaviors. You might gasp, your face may contort, and you might recoil. And finally, you have the subjective, conscious experience of the feeling itself, the sensation of being afraid. The relationship between these components has been the subject of a long-standing debate in psychology. One of the earliest theories, the James Lange theory, proposed by William James and Carl Lange, offers a counterintuitive perspective. This theory suggests that our emotional experience follows our physiological response. In other words, we feel afraid because we tremble. We feel sad because we cry. According to this view, we first perceive a stimulus in the environment, which triggers a specific pattern of physiological arousal and behavior, and our brain then interprets that bodily state as a particular emotion. A competing theory, the Cannon-Bard theory, argues against this sequence. It proposes that we experience physiological arousal and the emotional feeling simultaneously. When confronted with a threat, the theory suggests, the brain sends signals that trigger both the bodily response, such as a racing heart, and the subjective experience of fear at the very same time. Let that concept settle in. The connection between your body and your feelings is so intimate that theorists have long debated which comes first, the physical reaction or the conscious emotion. A more contemporary view, the Shachter-Singer two-factor theory, integrates these ideas. This theory suggests that emotion depends on two factors, physiological arousal and a cognitive label. First, we experience a general, undifferentiated state of physiological arousal. Then, we immediately search our environment for cues to help us interpret that arousal, and we cognitively label the arousal based on the context. In a classic experiment, participants who were given a stimulant experienced arousal. Those who were in a room with a euphoric Confederate labeled their arousal as happiness, while those in a room with an angry Confederate labeled it as anger. The same physical feeling was interpreted as two different emotions based on the social context. The real-world relevance of understanding motivation and emotion is profound. In the workplace, understanding the hierarchy of needs can guide management to not only provide fair compensation, which meets physiological and safety needs, but also to foster a sense of teamwork and belonging, and to provide opportunities for recognition and personal growth, which speak to the higher-level needs. Understanding emotion is the very foundation of emotional intelligence, which is the ability to perceive, understand, manage, and use emotions effectively in ourselves and in our relationships. It helps us understand why we might eat our feelings when stressed, using food to satisfy an emotional need rather than a physiological one. It also clarifies phenomena like the overjustification effect, where providing an external reward for an already intrinsically motivating activity can sometimes undermine the internal passion for it. Our motivations and emotions do not exist in a vacuum. They are profoundly shaped by the people around us. The desire for belonging, the feeling of pride or shame, the urge to conform or to help, all these are woven into a social fabric. This brings us to our next area of study, the powerful influence of the social world on the individual mind. Social psychology, the power of the situation. In our last lesson, we explored the internal drivers of behavior, our motivations and emotions. Yet, we are not isolated beings, we are deeply social creatures, embedded in a complex web of relationships and cultural influences. This segment shifts our focus from the inner world of the individual to the dynamic space between individuals. We will explore social psychology, the scientific study of how we think about, influence, and relate to one another. This field reveals a profound and sometimes unsettling truth, that the power of the social situation is often a much stronger determinant of our behavior than our internal disposition or personality. As you listen, consider the subtle and not so subtle ways the people around you shape your thoughts, feelings, and actions every day. A central theme in social psychology is social influence, how our behavior is shaped by the real or imagined presence of others. One of the most fundamental forms of social influence is conformity. Conformity is the adjustment of our own behavior or thinking to align with a group standard, often unspoken. We have a natural, often unconscious, tendency to want to fit in, to belong to the group. The classic demonstration of this power was a series of experiments conducted by Solomon Asch in the 1950 seconds. In these experiments, participants were shown a simple line and asked to match it to one of 3 other lines of different lengths. The task was intentionally easy. However, the participant was seated in a room with several Confederates people who were secretly working with the experimenter. These Confederates all gave the same, blatantly wrong answer. Faced with this unanimous but incorrect group opinion, a surprising number of participants conformed at least once, giving the answer they knew to be wrong rather than stand alone against the group. This reveals our powerful need for social acceptance, sometimes even at the cost of our own accurate perception. A more extreme form of social influence is obedience, which is acting in accordance with a direct order from a person perceived to have authority. The most famous and controversial investigations into obedience were conducted by Stanley Milgram. In his experiments, participants were told they were taking part in a study on memory and learning. They were assigned the role of teacher and were instructed to administer an electric shock to a learner who was actually a Confederate every time the learner made a mistake on a memory task. The shocks were not real, but the teacher believed they were. With each error, the voltage level increased, as labeled on the machine, to levels marked as danger, severe shock. When the learner began to pound on the wall and eventually fell silent, the experimenter, an authority figure in a lab coat, would prod the teacher to continue with phrases like, "The experiment requires that you continue." Despite obvious moral distress, a shocking majority of participants, about 2/3, continued to administer what they believed were painful, even lethal, shocks, simply because they were told to do so by an authority figure. This demonstrates the potent and sometimes dangerous power of obedience to authority in shaping human behavior. Beyond how we are influenced, social psychology also examines how we explain behavior. This process is known as attribution, our effort to understand the causes of our own and others' actions. We tend to make either a dispositional attribution, blaming the behavior on the person's internal characteristics, such as their personality, or a situational attribution, blaming the behavior on the external environment and context. For example, if a driver cuts you off in traffic, you are very likely to make a dispositional attribution, thinking, "What a rude and reckless driver." You are attributing their behavior to their character. It is far less common to make a situational attribution, such as considering, perhaps they are swerving to avoid something in the road, or they are rushing to the hospital. Let that concept settle in. Our minds have a default setting to explain others' behavior by their character, while often explaining our own behavior by our circumstances. This common cognitive bias leads us directly to one of the most pervasive and important concepts in social psychology, the fundamental attribution error. This is our tendency, when observing the behavior of others, to overestimate the influence of internal, dispositional factors and underestimate the impact of the external, situational factors. We see the other driver as inherently aggressive, but when we ourselves cut someone off, we know it was because we were distracted by a pressing concern. We see a person who is homeless and might attribute their situation to a lack of motivation, while underestimating the situational factors of catastrophic medical debt, job loss, or a lack of social support. The fundamental attribution error is a mental shortcut that simplifies our social world, but it does so at the cost of accuracy and compassion, often leading us to harsh and unfair judgments of others. The real-world relevance of these social psychological principles is immense and, at times, humbling. Understanding conformity helps explain how fashions and fads spread, and why it can be so difficult to be the lone dissenting voice in a business meeting or a political discussion. The lessons of Milgram's obedience studies echo in understanding how ordinary people can sometimes be compelled to commit extraordinary acts of cruelty within rigid hierarchical structures, such as in the military or in corrupt organizations. Awareness of the fundamental attribution error is a cornerstone of empathy and critical thinking. It encourages us to pause and consider the situational pressures someone might be under before judging their character. This knowledge also helps explain the bystander effect, a phenomenon where individuals are less likely to offer help to a victim when other people are present. The presence of others diffuses the sense of individual responsibility, and people look to the inaction of others as a cue that help is not needed. As we navigate this social world, we do not enter it as finished products. Our ability to relate, to conform, to lead, and to love is itself a product of a long and complex developmental journey. From the moment we are born, we are changing and being shaped by our experiences. This brings us to our next topic, where we will trace the remarkable path of human development from infancy to adulthood. Developmental psychology. From infancy to adulthood. In our last lesson, we explored how our thoughts and actions are shaped by the powerful influence of the social situation. But how do we become the social beings who are capable of being influenced, of conforming, of loving, and of leading? This journey begins at the very start of life. This segment delves into developmental psychology, the scientific study of the physical, cognitive, and social changes that occur throughout the human lifespan, from infancy through adulthood. We will trace the remarkable path of how a helpless newborn, equipped with immense potential, gradually transforms into a complex, thinking, and socially connected individual. As you listen, you might reflect on your own journey, recognizing the universal stages and unique experiences that have shaped who you are today. One of the most influential maps of cognitive development was charted by the Swiss psychologist Jean Piaget. Piaget proposed that children are not merely passive recipients of knowledge, but active constructors of their own understanding. He suggested that they progress through a series of 4 distinct stages, each characterized by a new way of thinking about the world. The journey begins with the sensorimotor stage, which spans from birth to about 2 years of age. In this stage, infants understand the world primarily through their sensory impressions and motor actions, looking, touching, mouthing, and grasping. A key achievement of this stage, which typically emerges around 8 months, is object permanence. This is the understanding that objects continue to exist even when they cannot be seen, heard, or touched. For a very young infant, when a toy is hidden under a blanket, it effectively ceases to exist. The acquisition of object permanence marks the dawn of a stable, external reality. From about 2 to 6 or 7 years, the child enters the pre-operational stage. This period is marked by a blossoming of symbolic thought, evidenced by the rapid development of language and the ability to engage in pretend play. However, the child's thinking is still not logical by adult standards. A hallmark of this stage is egocentrism. This does not mean selfishness, rather, it is the child's cognitive inability to take another person's point of view. A pre-operational child genuinely believes that if they can see you, you can see them, even if they are hiding under a table with only their feet visible. They assume that everyone else sees, hears, and feels exactly as they do. Next comes the concrete operational stage, lasting from about 7 to 11 years of age. In this stage, children develop the ability to think logically about concrete events. They grasp the concept of conservation, the understanding that quantity remains the same despite changes in shape. For instance, if you pour liquid from a tall, thin glass into a short, wide one, a pre-operational child will think the amount has changed. A concrete operational child, however, understands that it is still the same amount of liquid. They can also understand simple mathematical operations and begin to classify objects into hierarchies. Finally, at around 12 years of age and onward, individuals enter the formal operational stage. This is the peak of cognitive development, characterized by the ability to think abstractly. Adolescents and adults can now ponder hypothetical situations, reason deductively, and systematically formulate and test hypotheses. They can contemplate moral philosophies, imagine ideal worlds, and engage with abstract concepts like justice and freedom. Let that progression settle in. The mind of a child is not a miniature adult mind. It is a qualitatively different kind of mind, evolving through distinct and predictable phases of understanding. While Piaget focused on how children think, another psychologist, Erik Erikson, provided a compelling map of psychosocial development, outlining a series of 8 stages that span the entire human life. Erikson proposed that at each stage, we face a specific psychosocial crisis, a critical turning point that presents both a potential for healthy growth and a potential for failure. In infancy, the central crisis is trust versus mistrust. The infant learns whether the world is a safe and predictable place based on the consistency and reliability of their caregivers. The outcome of this stage lays the foundation for a sense of hope. In adolescence, the pivotal crisis is identity versus role confusion. The teenager grapples with the question, who am I? They must navigate and integrate various roles as a student, friend, and family member, to form a cohesive sense of self. Success leads to the virtue of fidelity, the ability to sustain loyalties freely pledged. A deeper dive into early development brings us to the crucial concept of attachment. Attachment theory, pioneered by John Bowlby and expanded through the careful research of Mary Ainsworth, emphasizes the profound importance of the emotional bond between an infant and their primary caregiver. Ainsworth devised a laboratory procedure known as the strange situation to observe attachment styles. She observed that when a secure attachment is formed, the infant uses the caregiver as a secure base from which to explore the world. When the caregiver leaves, the child may become distressed, but upon their return, the child seeks comfort and is easily soothed. This secure attachment, typically formed through responsive and sensitive caregiving, provides a foundation for a child to develop a sense of security, healthy self-esteem, and an ability to form strong relationships later in life. In contrast, insecure attachments, which can arise from inconsistent or neglectful care, can make a child either anxious, resistant, or avoidant in their relationships, patterns that can persist into adulthood. The real-world relevance of understanding developmental psychology is profound. For parents and educators, it provides a roadmap of a child's evolving capabilities. Understanding Piaget's stages helps a teacher know why a first grader cannot grasp abstract metaphors and needs hands-on learning, or why a teenager is suddenly capable of debating ethical dilemmas. Knowledge of Erikson's stages helps us appreciate the unique challenges of each phase of life, from fostering autonomy in a toddler to supporting an adolescent's search for identity. Awareness of attachment theory underscores the lifelong impact of early nurturing relationships and informs therapeutic approaches aimed at helping adults understand and heal from early relational wounds. As we develop from infancy through adolescence, one of the key outcomes of this long journey is the formation of a stable and enduring sense of self. This consistent pattern of thinking, feeling, and acting that defines each of us becomes the focus of our next area of study. This brings us to the psychology of personality. Personality, the enduring self. Our journey through developmental psychology traced the remarkable path of how we become unique individuals, shaped by our cognitive growth and social experiences. One of the key outcomes of this long journey is the formation of a stable and enduring sense of self. This segment focuses on that very essence: personality. Personality can be defined as an individual's characteristic pattern of thinking, feeling, and acting. It is the consistent, long-lasting set of traits and attributes that distinguish us from one another. Throughout history, psychologists have proposed different theories to describe the structure of personality and explain its origins. In this lesson, we will explore the most influential of these frameworks, each offering a distinct lens through which to understand the human character. As you listen, you might gently observe the patterns that feel most familiar in your own way of being in the world. One of the earliest and most comprehensive theories emerged from the work of Sigmund Freud. His psychoanalytic perspective proposed that personality is shaped by unconscious conflicts among fundamental psychological forces. Freud described the mind as having three interacting systems. The first is the id, which is present from birth. The id is a reservoir of unconscious psychic energy that operates on the pleasure principle, demanding immediate gratification for all primal drives and desires, such as hunger, thirst, and sex. It is the impulsive, infantile part of our psyche. The second system is the ego, which develops in early infancy. The ego operates on the reality principle, striving to satisfy the id's desires in ways that are realistic and socially appropriate. It is the executive mediator, often suppressing the id's urges until the time and place are suitable. The third system is the superego, which emerges around age 4 or 5 as we internalize the moral standards and ideals of our parents and society. The superego is our moral compass, our sense of conscience, and it judges the actions of the ego, producing feelings of pride or guilt. According to Freud, a healthy personality is one in which the ego can successfully manage the constant conflict between the impulsive id and the moralistic superego. He believed that anxiety arises when this balance is disrupted, and that we use unconscious defense mechanisms, like repression or denial, to protect the ego from this anxiety. While Freud's theory was revolutionary in its focus on the unconscious, it was also highly controversial and difficult to scientifically test. This led to the development of other, more empirically grounded approaches. A very different perspective is offered by trait theory. Unlike Freud, who was interested in the hidden dynamics of personality, trait theorists are primarily concerned with describing the basic dimensions of personality. Their goal is to identify and measure the fundamental traits that characterize an individual. Think of a trait as a relatively stable predisposition to behave in a certain way. One of the most influential models in modern psychology is the Big Five theory, which proposes that personality can be effectively described along 5 broad dimensions. The first is openness, which ranges from imaginative and curious on one end to practical and conventional on the other. The second is conscientiousness, which spans from organized and disciplined to careless and impulsive. The third is extroversion, which contrasts outgoing and energetic behavior with solitary and reserved tendencies. The fourth is agreeableness, extending from compassionate and trusting to competitive and critical. The fifth is neuroticism, which ranges from anxious and moody to emotionally stable and calm. This framework suggests that our individual personality is a unique blend of these 5 continuous dimensions. Let that concept settle in. One perspective delves into the unconscious drama of the mind, while another maps the stable, describable landscape of our characteristic traits. A third major perspective emerged in reaction to both psychoanalysis and behaviorism. This is the humanistic approach, which focused on the potential for healthy personal growth and the drive towards self-actualization. Humanistic psychologists, such as Carl Rogers, believed that we are inherently good and possess an innate tendency to grow and fulfill our potential. Rogers argued that the core of personality is the self-concept, our organized set of beliefs and feelings about ourselves. For a person to develop a healthy self-concept and progress toward becoming a fully functioning person, Rogers identified several key conditions. The most important of these is unconditional positive regard. This is an attitude of total acceptance toward another person, regardless of what they say, feel, or do. It means valuing a person for who they are, without any conditions of worth. In an environment of unconditional positive regard, a person does not have to hide or distort their experiences to feel accepted. They are free to explore all aspects of themselves and grow in a direction that is true to their own nature. This contrasts with conditional positive regard, where love and acceptance are dependent on behaving in certain ways, which can lead to a distorted self-concept and psychological tension. The real-world relevance of understanding these personality theories is both personal and professional. Freud's concepts, though often criticized, have profoundly influenced Western thought and provided the foundation for many forms of psychotherapy that explore how past experiences and unconscious processes shape our present behavior. The Big Five trait model is widely used in psychological research and has practical applications in career counseling and organizational psychology, helping to match individuals to work environments that suit their natural tendencies. The humanistic perspective, with its emphasis on unconditional positive regard, has had a transformative impact on therapeutic practices, teaching counselors and parents alike the profound power of empathy, authenticity, and acceptance in fostering human growth and well-being. Understanding that personality can be viewed through these different lenses encourages a more nuanced and compassionate view of ourselves and others, recognizing the complex interplay of our hidden drives, our measurable traits, and our innate striving for growth. Sometimes, however, the patterns of thinking, feeling, and acting that make up our personality can become rigid, distorted, or maladaptive, causing significant distress and impairing our ability to function. This leads us from the study of healthy personality to our next essential topic: The study of psychological disorders. Psychological disorders. Understanding abnormality. In our last lesson, we explored the enduring patterns that form our personality. Yet, sometimes, these patterns of thinking, feeling, and behaving can become rigid, distorted, or maladaptive, leading to significant distress and an impaired ability to function in daily life. This segment introduces the study of psychological disorders. Our goal is to understand these conditions not as moral failings or character flaws, but as clinical conditions that can be defined, studied, and treated. We will explore how the field of psychology distinguishes between typical human struggles and clinically significant disorders, and we will examine the major frameworks for understanding their origins. As you listen, approach this topic with a sense of compassionate curiosity, for understanding is the first step toward reducing stigma and fostering healing. The first and most fundamental question is, how do we define a psychological disorder? It is a complex question, but psychologists generally agree on several key criteria. A psychological disorder is typically characterized as a clinically significant disturbance in an individual's cognition, emotion, regulation, or behavior. This disturbance reflects a dysfunction in the psychological, biological, or developmental processes that underlie mental functioning. It is not merely an expected or culturally sanctioned response to an event, such as grieving the loss of a loved one. Most importantly, this disturbance leads to significant distress or disability in social, occupational, or other important areas of functioning. In other words, it causes real suffering and interferes with a person's life. It is also important to note that socially deviant behavior, such as political or religious nonconformity, is not in itself a psychological disorder unless it also stems from a dysfunction within the individual. To bring consistency and clarity to this complex field, clinicians use a common diagnostic guide. The primary tool used in the United States and many other countries is the Diagnostic and Statistical Manual of Mental Disorders, now in its 5th edition, and commonly known as the DSM-5. This manual provides a detailed classification system for psychological disorders. For each recognized disorder, the DSM-5 lists specific diagnostic criteria, a set of symptoms that must be present for a certain duration and that cause significant impairment. This system aims to improve the reliability and accuracy of diagnoses, ensuring that different clinicians use the same language when diagnosing the same set of symptoms. Think of the DSM not as a definitive Bible, but as a constantly evolving and carefully constructed guidebook, a work in progress that reflects the current scientific understanding of mental health. Within the vast landscape of the DSM, there are several major categories of disorders. One broad category is anxiety disorders. These are characterized by excessive fear and anxiety, and the behavioral disturbances that result from these emotional states. Fear is a response to a real or perceived immediate threat, while anxiety is the anticipation of a future threat. In disorders such as generalized anxiety disorder, panic disorder, and specific phobias, the anxiety becomes so persistent and overwhelming that it is debilitating. Another major category is mood disorders. These involve severe disturbances in mood and emotion, such as prolonged and intense periods of sadness or extremes of elation. The most common of these is major depressive disorder, which is characterized by a profoundly sad, empty, or irritable mood, accompanied by physical and cognitive changes that significantly interfere with the ability to function. It is more than just sadness. It is a pervasive state that can drain the vitality from life. A third category, which represents a more severe break from reality, is schizophrenia spectrum disorders. Schizophrenia is characterized by a range of symptoms that can include delusions, which are fixed, false beliefs, hallucinations, which are sensory experiences in the absence of an external stimulus, disorganized thinking and speech, and markedly abnormal motor behavior. These symptoms often cause immense social and occupational dysfunction. Let that concept settle in. These are not choices or weaknesses, but profound disturbances in the fundamental human experiences of thought, mood, and perception. To understand the origins of these disorders, we must look at the fundamental models that guide our thinking. For much of the past century, the dominant paradigm has been the medical model. This model views psychological disorders as sicknesses, much like physical diseases. It assumes that these disorders have underlying biological causes, such as genetic predispositions, biochemical imbalances, or abnormalities in brain structure and function. This perspective has been incredibly valuable, leading to the development of psychotropic medications that can correct or manage these biological imbalances, providing relief to millions. However, an exclusively biological view can be limiting. This has led to the widespread adoption of the more comprehensive biopsychosocial approach. This model assumes that psychological disorders are influenced by the complex interaction of three sets of factors. The bio refers to biological factors, such as our genetic inheritance, our neurochemistry, and the functioning of our nervous system. The psycho refers to psychological factors, such as our personality, our learned patterns of thinking, our emotional responses, and our early childhood experiences. The social refers to social factors, such as our cultural context, our family relationships, our socioeconomic status, and the level of stress in our environment. For example, a person might have a genetic vulnerability for depression, but the disorder may only be triggered by a psychological factor, like a tendency toward negative thinking. Combined with a social stressor, like the loss of a job, this integrated approach provides a much richer and more complete understanding of the origins of psychological distress. The real-world relevance of this knowledge cannot be overstated. Accurate diagnosis, guided by tools like the DSM, is the essential first step toward effective treatment. It allows individuals to put a name to their suffering and to understand that they are not alone. Understanding the biopsychosocial model helps to dismantle the stigma that has long been associated with mental illness. It frames these conditions not as personal failings, but as real health conditions arising from a complex interplay of factors, many of which are outside an individual's control. This perspective fosters compassion, both from society and from individuals toward themselves, and it opens the door to a multifaceted approach to healing. With a clearer understanding of what psychological disorders are and how they arise, our next logical step is to explore the various pathways to recovery. This brings us to the diverse and hopeful world of treatment and psychotherapy. Introduction to Psychotherapy: The Path to Healing. In our last lesson, we explored the nature of psychological disorders, understanding them as complex conditions that cause significant distress and impairment. But knowledge of a problem is only the beginning. The next, and most hopeful step, is the pursuit of solutions. This segment introduces the world of psychotherapy, the informed and intentional interaction between a trained therapist and someone seeking to overcome psychological difficulties or achieve personal growth. Psychotherapy, often called talk therapy, is not a single method, but a diverse landscape of approaches, each grounded in a different theory of human nature and change. As you listen, set aside any preconceptions and open your mind to the various pathways that can lead toward healing, resilience, and a more fulfilling life. The history of modern psychotherapy is often traced back to the psychoanalytic approach pioneered by Sigmund Freud. Derived from his theories of personality, this form of therapy aims to bring unconscious conflicts into conscious awareness. The central assumption is that many of our psychological struggles stem from repressed impulses and childhood conflicts buried deep in the unconscious mind. The psychoanalytic therapist employs techniques such as free association, where the patient is encouraged to say whatever comes to mind without censorship, and dream analysis, exploring the latent content of dreams believed to represent unconscious wishes. The therapist acts as a relatively blank slate, and the patient's feelings toward the therapist, a process known as transference, where they may unconsciously project feelings about important figures from their past onto the therapist, becomes a key tool for understanding old, unresolved patterns. The goal is to achieve insight, to understand the root causes of one's distress, and through this understanding, to release the grip of the past on the present. While classic psychoanalysis is less common today, its emphasis on the unconscious and the influence of early experience has left an indelible mark on the field. In stark contrast to the probing, past-oriented focus of psychoanalysis, the humanistic approach emerged as a more optimistic and present-centered alternative. Often called the third force in psychology, humanistic therapy focuses on the client's current subjective experience and their innate potential for self-actualization. The most influential figure in this tradition is Carl Rogers, who developed client-centered therapy. Rogers believed that people are inherently good and have a natural drive to grow and become their best selves. He proposed that the therapist's role is not to diagnose or interpret, but to facilitate this growth by providing a very specific psychological environment. This environment is built on three core conditions. The first is unconditional positive regard, which is a posture of complete acceptance and non-judgmental warmth toward the client, no matter what they express. The second is empathy, the therapist's sensitive and accurate ability to see the world from the client's internal frame of reference and to understand their feelings. The third is genuineness, or congruence, meaning the therapist is authentic, transparent, and real in the relationship. In this safe and nurturing climate, Rogers believed, clients are free to explore their true feelings, reduce the incongruence between their ideal and real self, and move toward becoming a more fully functioning person. Let that concept settle in. One therapy seeks to excavate the hidden past, while another seeks to nurture the growth potential in the present moment. Perhaps the most widely practiced and empirically validated approach in modern clinical practice is cognitive behavioral therapy, commonly known as CBT. This is a practical, action-oriented, and typically short-term form of therapy that focuses on the intricate connection between our thoughts, our feelings, and our behaviors. The fundamental premise of CBT is that our emotional and behavioral reactions are not determined by situations themselves, but by our interpretations of those situations, our thoughts and beliefs. For example, it is not the event of giving a presentation that causes anxiety, it is the thought, "I am going to embarrass myself and everyone will think I am incompetent," that triggers the feeling of anxiety and the behavior of avoidance. A cognitive behavioral therapist works collaboratively with the client to first identify these negative automatic thoughts and the underlying core beliefs that fuel them. Then, the therapist helps the client to challenge and restructure these dysfunctional thought patterns, testing their validity and replacing them with more realistic and adaptive alternatives. This is the cognitive part. The behavioral part involves actively changing behavior patterns. A client with social anxiety might be assigned behavioral experiments, such as engaging in a brief small-talk conversation to test their fearful predictions and build confidence. CBT is a highly structured and skills-based approach, equipping clients with practical tools they can use for the rest of their lives. In many cases, particularly for severe disorders like major depression, bipolar disorder, or schizophrenia, psychotherapy is combined with biomedical therapies. These are treatments that directly alter biological functioning, primarily through the use of psychotropic medications. These drugs work by influencing the levels of various neurotransmitters in the brain. Antidepressants, for instance, may increase the availability of serotonin or norepinephrine. Anti-anxiety drugs typically depress central nervous system activity. Antipsychotic drugs often block dopamine receptors. The goal of medication is not to solve all of life's problems, but to stabilize brain chemistry, reduce the most debilitating symptoms, and create a stable foundation from which a person can effectively engage in psychotherapy and daily life. The real-world relevance of understanding these therapeutic approaches is to realize that there is no single best therapy for everyone. Different approaches work for different people and different problems. A person seeking deep insight into long-standing personality patterns might benefit from a psychodynamic approach, Someone feeling lost and seeking personal growth might thrive in a humanistic environment. A person struggling with the specific, intrusive thoughts of anxiety or depression will likely find powerful relief through the structured techniques of CBT. Many modern therapists use an integrative or eclectic style, thoughtfully blending techniques from various schools to best meet the unique needs of each individual client. Seeking therapy is not a sign of weakness. It is a proactive step of strength, a commitment to understanding oneself and cultivating a healthier, more resilient mind. Healing from profound distress is a vital part of the story, but psychology's scope extends beyond treatment to the broader question of how we can all live better. Our final lesson will connect the mind and body by exploring the psychology of stress, health, and the cultivation of well-being. Stress, health, and well-being. In our previous lesson, we explored the various pathways of psychotherapy, the tools for healing when psychological distress becomes overwhelming. But the mission of psychology is not only to restore us to a neutral state, but to understand what allows us to thrive. This final segment connects the mind and body by exploring the psychology of stress, health, and well-being. We will examine how we respond to life's challenges, how we can cope more effectively, and how we can actively cultivate a life of meaning and fulfillment. As we conclude our comprehensive journey, let this lesson be a gentle guide toward integrating this knowledge into a deeper understanding of your own capacity for resilience and growth. Let us begin with the concept of stress. In psychological terms, stress is not an event itself, but the process by which we perceive and respond to certain events, called stressors, that we appraise as threatening or challenging. Our response to stress is a complex mind-body event. A classic model for understanding this physiological response is the general adaptation syndrome described by Hans Selye. This syndrome unfolds in 3 stages. The first stage is the alarm reaction. This is your body's immediate fight or flight response to a stressor. Your heart pounds, your muscles tense, and your breath quickens as your sympathetic nervous system mobilizes you for action. It is an ancient, survival-based alarm system. If the stressor persists, you move into the second stage, resistance. Here, your body remains on high alert, but it can no longer sustain the intense initial arousal. You may adapt to the ongoing stress, but you are expending a great deal of physiological resources to do so. You become more vulnerable to illness, as energy is diverted away from non-essential systems, such as your immune response. If the stress is severe and prolonged, you may enter the final stage, exhaustion. At this point, your body's reserves are depleted, and your ability to cope collapses. This stage can lead to physical wear and tear, increasing the risk of stress-related illnesses like hypertension, digestive issues, and profound fatigue. How we navigate this process depends greatly on our resources for coping. Coping refers to the thoughts and behaviors we use to manage the internal and external demands of situations we appraise as stressful. Psychologists often distinguish between 2 broad coping strategies. The first is problem-focused coping. This strategy involves attempting to take control of the stressor itself by directly addressing the problem. If you are stressed by an overwhelming workload, problem-focused coping would involve creating a detailed schedule, delegating tasks, or speaking with your manager about your capacity. It is about changing the situation. The second strategy is emotion-focused coping. This involves attempting to manage your emotional response to the stressor. When a problem is beyond your direct control, such as receiving a difficult medical diagnosis, emotion-focused coping becomes essential. It might involve seeking emotional support from friends, reframing the situation in a more positive light, or engaging in relaxation techniques to soothe your nervous system. It is about changing how you feel about the situation. The most resilient individuals are often those who can flexibly employ both strategies, knowing when to change the world around them and when to change their perspective within it. Let that concept settle in. Resilience is not the absence of stress, but the capacity to navigate it with a diverse and flexible toolkit of responses. While understanding stress and coping is crucial, The field of psychology has more recently turned its attention to what makes life worth living, even in the face of adversity. This movement is known as positive psychology. Spearheaded by figures like Martin Seligman, positive psychology shifts the focus from repairing what is broken to building what is positive. It is the scientific study of human flourishing and the factors that allow individuals and communities to thrive. Positive psychology does not ignore suffering or disorder, but it complements our understanding by asking what constitutes a life well lived. Seligman's well-known model of well-being, often summarized by the acronym PERMA, suggests several key elements. The P stands for positive emotion, which involves cultivating feelings like joy, gratitude, and serenity. The E is for engagement, the state of being fully absorbed and immersed in an activity, a concept closely related to flow. The R is for relationships, the strong social connections that are fundamental to our happiness and health. The M is for meaning, belonging to and serving something that you believe is bigger than yourself. And the A is for accomplishment, the pursuit of achievement and mastery for its own sake. The real-world relevance of this knowledge is both practical and profound. Understanding the stress response system underscores the vital importance of stress management techniques. Practices such as mindfulness meditation, regular physical exercise, and ensuring adequate sleep are not luxuries. They are essential maintenance for your biological stress response machinery, helping to activate the parasympathetic nervous system and promote the rest and digest state. Understanding coping strategies empowers you to consciously choose how to face challenges, reducing the feeling of helplessness that often amplifies stress. And the principles of positive psychology provide a blueprint for proactive mental health. Actively cultivating gratitude by keeping a simple journal, investing time in deep and meaningful relationships, identifying and using your signature strengths in daily life, and pursuing activities that induce a state of flow. These are all evidence-based practices that can elevate your baseline level of well-being and build psychological resilience against future stressors. And with that, we conclude our comprehensive journey through the fundamentals of psychology. We began with the very definition of the science of mind and behavior, and we have traveled together through the biological foundations of the brain, the processes of sensation and perception, the principles of learning and memory, the complexities of thought and language, the drivers of motivation and emotion, the power of the social situation, the journey of development, the structure of personality, the nature of psychological disorders, the paths to healing, and finally, the science of well-being. This knowledge is a tool for better understanding yourself and others, for cultivating compassion, and for navigating the human experience with greater wisdom and resilience. Let these concepts settle in your mind. Your learning journey continues, even in rest. Thank you for listening.